In section 4, we're now going to talk about valence bond theory. So we're not going to have to go too much into depth with this, but it is important to talk about. So first of all, what is valence bond theory? Well, we've been talking a lot about how atoms bond, chemical bonding, we've been talking about ionic and covalent, all kinds of things, right? But we really haven't talked much about what actually is happening at the atomic orbital level when something like bonding happens, right? When two atoms bond together, okay, we get the idea that in a covalent bond, electrons are shared, but we really haven't gone at the molecular and atomic level to discuss what's actually happening, right? And so valence bond theory is one basic theory that attempts to explain what is actually happening at the atomic orbital level when two atoms combine together in a chemical bond. So we're essentially looking at everything we learned in quantum mechanics back in topic 3. So we don't need to go into detail here. We're just going to cover it from a very basic level, and that's it. So when atoms share electrons, which remember that's what's known as a covalent bond, that's going to happen when a singly occupied atomic orbital on the first atom overlaps with a singly occupied atomic orbital on the second atom. So as an example, let's consider the bond between a hydrogen and a chlorine. Okay, so let's think about it in the simple way that we've been talking about. So hydrogen has its 1 valence electron and chlorine has its 7 valence electrons. And so what we've learned so far is that, okay, well, when they come together, they're going to share these 2 electrons right there, and so it ends up looking something like this. So you've got these electrons here that are in the middle, and they're being shared. So now hydrogen feels like it's got its full octet. Remember, hydrogen only needs 2, and chlorine has it. Great. That's kind of the basic or simple way of looking at it, but that really doesn't explain what's actually happening at the atomic orbital level. So let's go a little deeper. So if you were to take a look at hydrogen's electron configuration, hydrogen is 1s1, right? And so that one atomic orbital would have that one electron showing with the arrow pointing up, right? And then chlorine, now chlorine is, I'm gonna reference a noble gas here because we don't need the deeper stuff. We just need the valence electrons, right? So it references neon, and then it's 3s2, 3p5, right? And so that 1s orbital is filled with the 2 electrons, and then remember there's 3p orbitals, and you've got 1, 2, 3, 4, and then 5. Okay, so according to valence bond theory, in order for these 2 atoms to actually be able to bond together, you need a singly occupied orbital on one of the atoms and a singly occupied orbital on the other atom, and they're going to overlap. If you take a look at hydrogen, here is its singly occupied orbital, right? Its orbital has 1 electron in it. And if you take a look at chlorine, does it have an orbital that's singly occupied? Yes, it's right here. And I know that might be kind of hard to see, but this orbital right here has that 1 electron. And so the s orbital here for the hydrogen, so notice it says 1s, and the p orbital here for chlorine, which is why it's 3p, that singly occupied orbital on both, they just overlap. And that overlapping of the orbitals is what actually creates that bond. So the key thing I want you to understand from this theory is that in order for 2 atoms to actually come together and bond, to share those electrons, each atom needs to have a singly occupied orbital in order for it to overlap and create that bond, right? If the orbital is empty or if it's filled with 2, it can't bond. So that's the key thing. Let's look at one more example so you can see what I'm talking about. So let's take, for example, we're looking at the fluorine molecule, right, which is 2 fluorines coming together. According to what we just learned in valence bond theory, for this to happen, each fluorine has to have a singly occupied orbital. So I actually already have here on the screen the orbital diagram for each fluorine. Obviously they're going to be the same because they're both the same element. And if you take a look at fluorine, does it have a singly occupied orbital? Yes, it does, right here. Obviously, this fluorine also has a singly occupied orbital. And so if you take a look at the atomic orbital image down below, before they bond, you see this translucent p orbital here and this translucent p orbital there. That indicates that that's the singly occupied orbital. And so what they do is they come together and overlap right here, and now that's actually what creates the bond. So that's it for valence bond theory. Obviously, it does go a little bit more in depth, but that's really all we need to understand here. And also understand, let me go back just a second because I forgot to mention this earlier, that when these atoms do bond, when bonds are created, energy is released. And that's actually why atoms bond, because as the result, the resulting molecule ends up being lower in energy. And that is, of course, favorable for the particular substances. So that wraps up valence bond theory. We're going to see in the next video for hybridization.